In this video, we will define relationships, we will discuss our business scenario and its corresponding data model diagram. We will then use this diagram to build a Tableau data source that includes relationships. Once we've built our data source, we'll use it to answer some important business questions. Along the way, we'll learn various aspects of the interface and the functionality of key features. This will include looking at the layout of the data pane, exploring how to show or hide null values, creating calculations using fields from multiple tables, and using the auto-generated count fields. Lastly, we'll fine-tune our performance options settings, such as cardinality and referential integrity. What are relationships? Relationships are the noodles that connect related tables on the Tableau data source page. They define how data source tables relate to one another based on common fields. Relationships provide several key benefits. A single data source can answer a wide variety of business questions. Relationships also enable an intuitive analytics experience for all types of users. Data sources are easy to create and are optimized for efficiency, leading to fast reporting. Before jumping into Tableau Desktop, let's familiarize ourselves with our business scenario. We own a convenience store. We want to analyze our transaction data to answer business questions. Our convenience store sells 8 products. Each product has a unique product ID, a product name, unit price, and unit cost. Each product falls into one category. Each category has many products. The line between the tables signifies this one-to-many relationship. The two tables relate based on a common field, category ID. Many transactions occur each day. Each transaction has a unique transaction ID. Some customers use our reward card system during a transaction. This provides us with a partial list of customers. Doug was a repeat customer in transactions 1 and 3. Transaction 4 had an unknown customer. There is a one-to-many relationship between the customer table and the transaction table. The two tables relate based on a common field, customer ID. How do transactions and products relate? A transaction can have many products. A product can appear in many transactions. This is a many-to-many relationship. Since there is no common field between the two tables, good database design would resolve this issue by adding a transaction detail table in the middle. Transaction ID combined with product ID uniquely identify each row. The quantity sold is also recorded. During transaction 1, 2 magazines and 1 water were purchased. The many-to-many relationship between the transaction table and the product table has been replaced by 2 one-to-many relationships. Now that we understand our data model diagram, let's build this out in Tableau Desktop. Open Tableau Desktop. On the Start page, connect to a Microsoft Excel file. Select the Convenience Store spreadsheet and select Open. On the Data Source page, our 5 tables are located on the left. We'll start by bringing in our most detailed level table. Drag the Transaction Details table to the canvas. A preview of the table's contents will appear below. As we bring in the remaining tables one by one, our data source will resemble our data model diagram rotated by 90 degrees. Drag the product table onto the canvas to the right of the Transaction Details table. Notice the noodle that represents the relationship between the two tables. The Edit Relationship window will appear. Tableau Desktop has automatically related the two tables based on a common field, product ID. We could also manually select the common fields. There are performance options settings available. For now, we'll use the default settings. Close the Edit Relationship window. From the left, drag the Transactions table onto the canvas to the right of the Transaction Details table. Confirm that the tables are related based on Transaction ID. Close the Edit Relationship window. From the left, drag the Category table onto the canvas to the right of the Product table. Let's see what happens if we accidentally connect it to the wrong table. Notice the warning that there is no common field between the two tables. To fix our drag and drop mistake, close the Edit Relationship window, then use the drop-down of the Category table and select Move to and then Product to move the Category table to the right of the Product table. The tables will relate based on the common field, Category ID. Close the Edit Relationship window. Lastly, drag the Customer table onto the canvas to the right of the Transaction table. The tables will relate based on the common field, Customer ID. Close the Edit Relationship window. From the File menu, select Save. We'll save as type Tableau Packaged Workbook so as to embed the data within the workbook. Name the file as Convenience Store. Click Save. Click on Sheet 1. On the left is the data pane. Notice that the fields are organized by table. Within each table, a horizontal line separates the dimensions from the measures. Each table contains an automatically generated field that is a count of the number of rows in the table. Let's format unit cost and unit price as currency. For each, use the drop-down, Default Properties, Number Format, Currency Standard, and click OK. Save the workbook. Let's answer a few business questions. Question 1. What were our best and worst selling products? Also display the product IDs. From the product table, drag product name to the rows. From the transaction details table, drag quantity sold to the columns. Sort by quantity sold in descending order. Set the fit to entire view. Our best-selling product was water. Our worst-selling products were pencils and pens, which were not sold in any transactions. To limit the results to products that actually sold, click on the Two Nulls indicator and then on Filter Data. This filters quantity sold to non-null values only. Let's undo this filter, since the unsold items are important to see. Let's move on to displaying the product ID. It is a common field between the product table and the transaction details table. It matters which table we drag product ID in from. If we drag it in from the transaction details table, we will only see the 6 products that were sold. Let's instead drag the product ID in from the product table. This displays the complete list of products. Sort the bar chart again. Rename the sheet as Best and Worst Selling Products. Save the workbook. Open a new worksheet. Question 2. What was the contribution margin per product? Contribution margin equals unit price minus unit cost. Let's create a calculated field. Name it contribution margin. From the product table, drag in unit price. Type a minus sign, then drag in unit cost. Click OK. Notice that contribution margin appears within the product table. That is because it is based on fields that come from that one table only. Let's format contribution margin as currency standard. We will validate our calculation by creating a text table. Hold down the Control or Command key on your keyboard while selecting product name, contribution margin, unit cost, and unit price. At the top right, click on Show Me. Select Text Table, and then click Show Me again to close it. From the toolbar, change the fit from Standard to Entire View. On the Measure Values shelf, rearrange the measures into the following order: unit price, unit cost, contribution margin. We can clearly see that unit price minus unit cost is leading to correct contribution margin values for each product. Rename the sheet as Contribution Margin per Product. Save the workbook. Open a new worksheet. Question 3. What were the sales revenue, profit, and profit margin per category and product? We'll create 3 calculated fields. Name the first one Sales Revenue. From the transaction details table, drag in quantity sold. Type an asterisk, which is the multiplication symbol. Then, from the product table, drag in unit price. Click OK. The new sales revenue measure appears at the bottom of the data pane. That is because it is based on fields from multiple tables and therefore cannot be placed within any one table above. Format sales revenue as currency standard. The second calculated field we will create is profit. From the transaction details table, drag in quantity sold. Type an asterisk, then from the product table, drag in contribution margin. Click OK. Profit also appears at the bottom of the data pane since it uses fields from multiple tables. Format profit as currency standard. The third calculated field we will create is profit margin. The formula is the sum of profit divided by the sum of sales revenue. This is an aggregate calculation because we are using the sum aggregation within the formula. It's important here to sum before dividing instead of the other way around to avoid incorrect profit margin percentages that would sum to greater than 100%. Click OK. Aggregate calculations always appear at the bottom of the data pane. Format profit margin as a percentage with one decimal place. We will validate our numbers in a text table. Hold down the Control or Command key on your keyboard while selecting category name, product name, profit, profit margin, and sales revenue. At the top right, click on Show Me. Select Text Table and then click Show Me again to close it. From the toolbar, change the fit from Standard to Entire View. On the Measure Values shelf, rearrange the measures into the following order: profit, sales revenue, profit margin. Notice that the profit divided by the sales revenue is leading to correct profit margin percentages for each product. To confirm that the percentages are correct at the category level, go to the Analysis menu, Totals, and add all subtotals. The subtotal values are correct. Let's also show column grand totals. The grand total values are also correct. Rename the sheet as Profit, Sales Revenue, and Profit Margin per category and product. Save the workbook. Open a new worksheet. Question 4. Who are our most frequent customers? From the Customer table, drag Customer Name to the rows. From the Transaction table, drag the automatically generated Transaction Count field to the columns. Sort by Transaction Count in descending order. We see that Doug was our most frequent customer. Additionally, the unknown customer from transaction number 4 is included in our comparison. Rename the sheet as Count of Transactions per Customer. Save the workbook. Open a new worksheet. Question 5. Who were our most profitable customers? This question brings together data from 4 of our 5 tables. From the Customer table, drag Customer Name to the rows. From the bottom of the data pane, drag Profit to the columns. Sort by profit in descending order. We see that Doug was our most profitable customer. Rename the sheet as Profit per Customer. Save the workbook. Open a new worksheet. Question 6. From which categories did each customer purchase, and in what quantity? This question brings together data from all 5 of our tables. From the Customer table, drag Customer Name to the rows. From the Category table, drag Category Name onto the rows to the right of Customer Name. From the Transaction Details table, drag Quantity Sold to the columns. Sort by quantity sold in descending order. The results correctly reflect all the transactions that occurred. Rename the sheet as Quantity Sold per Customer and Category. Save the workbook. Performance options are optional settings we can specify when defining relationships between tables. The default settings ensure that no data goes missing in our visualizations. We can adjust the settings to improve performance. We define the settings based on our data model diagram and our business rules. Consider the following questions regarding our business rules. Can a customer have no transactions? Can a transaction have no customer? Can two customers split a transaction? Can a category have no products? Can a product have no category? Can a product be in multiple categories? Since Tableau Desktop cannot assume the answers to these questions, it must consider all of these options to be valid. Let's define our business rules so as to maximize query performance. We will define these business rules as we adjust our performance options settings. One category can have many products. A product belongs to one category only. Some categories have products. This means that a new category can be added before assigning products to it. All products must belong to a category listed in the category table. One customer can complete many transactions. A transaction is completed by one customer only. Therefore, two customers cannot split a transaction. All customers have completed at least one transaction. Some transactions were completed by customers listed in the customer table. Other transactions were not. One transaction can have many transaction details. A transaction detail belongs to one transaction only. All transactions have transaction details. All transaction details belong to a transaction listed in the transaction table. One product can appear in many transaction details. Each transaction detail contains one product only. Some products appear in a transaction detail. Some products, such as pencils and pens, do not. All transaction details contain a product listed in the product table. The performance of our workbook is now improved, and the results in our visualizations are still the same. For additional help on the use of relationships, please visit help.tableau.com.
Tableau cannot write changes back to the data source. However, we can modify the metadata for use in Tableau directly in the data pane. There are a lot of features. We'll just go through a few examples. Fields we don't need can be hidden, like order priority. I've already hidden a lot of fields in the data source. We can rename fields. Click twice slowly, and we'll call this shipping date. We can create a hierarchy simply by dragging a subordinate field onto another field. We'll call this products. To add another field, simply drag it into the hierarchy. And we can always drag to rearrange the order. This creates the ability to drill down in the view. We can also create folders by right-clicking and selecting Group by Folder. Then right-clicking again to create a folder. We'll call this Customers. And then simply drag the fields into the folder. Collapsing these can be handy if there's a long list of dimensions or measures. A handy thing to know is that Tableau has this search function, which is helpful if fields are collapsed in folders or hierarchies. We can change the default data type, say row ID, by clicking on the icon in front of the field and changing the data type. We can assign default colors simply by bringing a field such as Market to Color and editing the colors. That choice will be remembered the next time we use the field. If we right-click on a measure and go to Default Properties, we see there are several features nested here, such as adding a comment, editing the default number format, and changing the default aggregation. Hovering over the field discount shows us that a comment has been added for that field. If we bring discount into the view, we see that it comes out as an average instead of the normal default sum, and turning on labels shows us that it has been formatted as a percentage. An important thing to note here is that all of this is part of the definition of the data connection, not actual changes to the underlying data. When using a published data source from Tableau Server or Tableau Online, we will not be able to do things like edit or remove existing hierarchies, aliases, or calculations. But we can extend metadata, such as authoring new calculations for use in the workbook. This will not write back to modify the original data source. To easily get back to the Data Connection window, simply click on the Data Source tab. You may be prompted to reconnect to the data source, including navigating to a flat file on your machine. Alternatively, if at any time we realize we need to modify the data connection, simply right-click on the data source to pull up the menu. This menu lets us control many aspects of the data connection, such as renaming it, turning on or off extracts, creating or editing data source filters, publishing or saving data sources. If we're already connected to a data source and decide that we'd like to extract it, we can do so by right-clicking on the data source and selecting Extract Data. Tableau gives us various options for customizing the extract. For more information about these options, check out the online help. For now, we'll leave everything as it is and hit Extract. If the workbook has already been saved as a .twbx packaged workbook, the extract will automatically save as part of the packaged workbook. If the workbook has been saved as a .twb or hasn't been saved yet, we'd be asked where to save the Tableau data extract file, .tde. Notice that the icon here has changed from a single cylinder to 2 cylinders with an arrow on it. This indicates that the data has been extracted from its native environment into the fast data engine. The original data is untouched. We can also see that the data has been extracted by right-clicking on the data source and noting that the Use Extract option is checked. If we want to switch back to a live connection, we can do so at any time simply by unchecking the Use Extract option. If the underlying file has been altered or moved, unchecking the Use Extract option may prompt us to replace the file. Simply navigate to the new location of the file. And now note the icon is back to that single cylinder. But let's turn the extract back on. Because we're currently connected to a static copy of the data, if the underlying data were to change, the view would not update with that new data until the extract is refreshed. To do this, we right-click on the data source, go to the Extract menu, and click Refresh. Published extracts can have their refreshes handled by Tableau Server or Tableau Online. Check out the online help for more information. We can also create an extract right when we connect to data for the first time. Let's connect to another data source, clicking on the Connect Data icon in the toolbar, and we'll select Excel and choose our file, available for download under the video, and select Open. On the data source page here, we'll click Extract, and then back onto our sheet. Now that we have 2 data sources, we can explore an important feature in Tableau Desktop, the ability to replace a data source. This process is great to know if, for example, you're using a local extract to build up a proof of concept before switching to a live production environment. We have 2 data sources. This blue check means that this is the primary connection currently being used in the viz. The link icons in the other data source mean we could do a data blend. To swap these out, we'll right-click on a data source and select Replace Data Source. We can easily see how the replacement will happen, and we click OK. Since we don't need the original data connection, we can close it by right-clicking and selecting Close. I'm sure you've noticed that there's a red pill outlining our average discount and a red exclamation mark next to our discount field. Looking above, we see there's another field called Disc%. This is the same data as discount, just named something different in the second file. If we right-click on our original discount field and select Replace References, we can tell Tableau that the discount field should actually be that Disc%. Now the warnings are gone, though we may need to re-establish the default aggregation. Imagine you've put a lot of effort into managing your metadata, re-aliasing fields, creating calculations, setting default colors, etc. You want to keep all those efforts to use again later. You can locally save a data source, making it easily available in your copy of Tableau Desktop. Or, to securely share a data source with others, it can be published to Tableau Online or Tableau Server. If we want to save a data source, we right-click on the data source itself and say, Add to Save Data Sources. This will save the connection as a .tds. Note, this is not the data itself, just the information about the connection. The data source will now be in the Save Data Sources list on your local copy of Tableau, making it readily available the next time you want to use it. Alternatively, data sources can be published to Tableau Server or Tableau Online. Once published, a data source can be used by anyone with the correct permissions. They don't have to install drivers or do data prep or curation themselves. All workbooks that use the published data source will automatically be updated when the data is refreshed or changed, maintaining a single source of truth. To publish a data source, open the Server menu. The first thing in the menu is either the information for what online or server site you're signed into or an option to sign in. You can always change where you want to publish the data source. Next, click Publish Data Source, then select which data source you want to publish. Choose the project where the data source should live, and if desired, we can rename the data source. Naming conventions across your organization can be very helpful. We can add a description so others know exactly what this data source is for, and we can even add tags. If the permissions are not locked to the project, they can be defined here. Permissions include the ability to do things like save, download, or just connect to the data source. There's also this option to update the workbook to the published data source, which is a handy way to keep the workbook up to date if the data source may change. If this box is left unchecked, we can continue to modify the data source in the workbook and use it to edit the published data source. To edit a published data source, we need to be connected to the original. We can say remove a field from a hierarchy or add a calculation. Then republish the data source. This will overwrite the existing one. Now, any workbooks using the published data source will be refreshed the next time they're opened with the new data structure, maintaining a single source of truth. The process for publishing data sources changes a little depending on if you're using Tableau Server or Tableau Online, and if you're working with a live data source, indicated by a single cylinder, or an extracted in-memory data source, indicated by a double cylinder. Publishing a live data source to Tableau Server follows exactly the process outlined above. If the data source requires credentials, there's an option to embed or prompt for them. Publishing an extract to Tableau Server has the added option of choosing a refresh schedule. These options are set by the server administrator. Because Tableau Online is in the cloud and therefore outside the firewall, the process is a little more complex. I'll switch and sign in to my online site. Tableau Online can directly maintain live connections to cloud-based services such as Google BigQuery and Amazon Redshift. If we're publishing an extract to Tableau Online, refreshing the extract is handled by the Tableau Bridge client. Now when we publish the data source, we're prompted to sign in to the Bridge client. Click Schedule using Tableau Bridge. We can select where the client should start, I'll stick with my computer, and we can set a schedule for refreshing the extract. I'll leave the defaults. For more information, refer to the online help. The Bridge client is now running in the Systems tray of my computer. Finally, if the site administrator has enabled live connections on Tableau Online, the Bridge client can handle live connections to on-premises data sources. The site admin will be the one to manage the client in those instances. Here, I'm prompted to create an extract on publishing, because the Tableau Online site that I'm trying to publish to does not have the Bridge enabled to support live connections. I can either reach out to the site admin and request that they enable this and add the data source to the Bridge, or I can publish an extract for now. Whether we've published to Tableau Server or Tableau Online, to manage published data sources, we navigate to Content and then Data Sources. And here we see a list of our published data sources. If they're live, or when they were last extracted, who owns them, and metrics around their usage. Clearly, this is a site that doesn't get much traffic. To manage things such as the owner, permissions, and revision history, open the Ellipses menu. Clicking on a data source brings us to its page, where we can manage things like refresh schedules. It's easy to create a workbook from a published data source, or to modify an existing workbook published to a Tableau site. But as a creator, you can also create a new workbook from your browser with a completely new data connection. To begin, click New Workbook, either from inside a project or the Workbooks tab. We're brought to the New Workbook authoring environment, and a window automatically opens to connect to data. There are 3 tabs: Files, Connectors, and On This Site. If you're only presented with a list of published data sources, no tabs for files or connectors, your role does not allow for new data connections. If you're a creator in a Tableau Online site, you also have access to a 4th tab for dashboard starters. Select from the common enterprise applications available and choose your desired template. When you sign into the application, your data will populate. But let's get back to our workbook. We can upload Excel or text-based files directly from our computer. Once connected, we see the same Data Source tab experience from Tableau Desktop. We can perform joins and unions, use the data interpreter, and perform basic cleaning operations such as splitting and basic pivots. Let's add another data source to explore the other options. Click the new data source icon in the toolbar. On the Connectors tab, we see a list of the data sources we can connect to directly from the web. Selecting one will prompt for the connection information, just as with Tableau Desktop. The On This Site tab, which is also visible to explorers who can publish, lists the data sources already published to the site. Here we can select which data source we want to connect to, and click Add Data Source to add it to the workbook. Once we do our analysis and save the workbook, we can navigate to the workbook and then to its data sources. Note that while the data is available in the workbook, it is not published as an independent data source. Connecting to data from the web is done in the context of a workbook and is not a substitute for publishing data connections to the site. Note that when we connect to data from the web, files are static and database connections are extracts. If the data needs to be kept fresh, either with live connections or scheduled extract refreshes, it's best to build workbooks off published data sources. Here we have a report in Excel showing the number of resolved incidents per employee per month. Formatted reports like this aren't easy to do analysis on. The Ideal tab shows data formatted like a database table, or raw data. This is the format Tableau prefers for optimal analysis. However, there are several features in Tableau Desktop to help automatically reshape text in Excel files into this format for better analysis in Tableau. To begin, we'll connect to this Excel file. In Tableau Desktop, select Excel from the Connect pane. navigate to the downloaded file and click to open. We'll drag out the Resolved Incidents sheet. Although Tableau can connect to this report, we see here in the preview that this isn't a great format. There are no column names, the headers from Excel have a lot of nulls, and so on. Here in the side panel, we see the option to use the data interpreter. Let's turn it on. Now we see that those headers and nulls have been stripped out and our columns are properly identified. We could go on, but if we want to get more specifics on what the data interpreter did, we can click Review Results. This will open an Excel file describing the changes. If we click to the tab we used, Resolved Incidents, we see which fields are being used as headers in red and which are considered data in green. Before we go back to Tableau and our data source, let's take one more look at that Ideal tab. Note that instead of having a column for each month with data underneath, in this format, there's a date column and each row contains the number of resolved incidents for a unique combination of date and employee. This data is taller with more rows rather than wider with more columns. Back in Tableau, we want to change the format from this column per month layout into a single date column and a single column for resolved incidents. To do this easily, we'll simply select all the date columns. Click on the first, scroll if necessary, and shift-click on the last. We'll open the menu and select Pivot. The Pivot feature essentially merges the information from the original columns and rows into two new columns, Pivot Field Names and Pivot Field Values. We can see that Pivot Field Names is actually our date, and Pivot Field Values can be renamed Resolved Incidents. We can double-click to rename. If we click on the icon here above the first column, we're brought to the metadata grid. This can be a useful view, as the vertical layout can be easier to navigate, especially if we have a large number of fields. It's also useful when tables have been joined or to see the original field names. For now, we'll go back to the standard view. Our data is almost where we want it to be, but there's one more thing we can do. Here, the employee field is actually two pieces of information, a location code, A, B, C, D, or E, followed by an employee number. We can split the column based on the shared delimiter of that hyphen. Click to open the menu and select Split. We'll use the metadata grid view and rename our split fields. Split 1 should be location, and split 2 should be employee ID. There's an ABC next to the date field, indicating that this column is considered a string. We know it's actually a date, though, so we can click on the ABC and select Date to update the data type. Now if we click onto Sheet 1, we'll see our nice tidy data ready for analysis. Let's bring Employee ID to the view and Resolved Incidents. When we sort, it's clear that there are really two groups of employees, some who resolve a much higher number of incidents than others, those who are Tier 2. If we add another data source, connecting to that same Excel file, we see that there's a sheet called Tiers. This report adds a -2 to the end of an employee ID if they're Tier 2. Because not all rows have this ending, a standard split won't work. However, we can use a custom split. Open the menu, choose Custom Split, and we can set our delimiter as a hyphen and mandate that we want to break off all columns. This forces Tableau to break off that third column with the Tier 2 indicator. Depending on your data source, Tableau Desktop offers several options for joins, including inner, left, right, and full outer joins. But what do the various join types mean? Joining tables is a way of combining information, that is, new fields or columns, from multiple tables based on a field they share. Joins are always made on a specific field or fields. Here at the top, we have two tables we want to combine. The table on the left contains sibling information, and the table on the right contains eye color information. We'll join these tables on the field they share, name. An inner join preserves only the rows that have the same key field, in our case name, between both tables. We only get information for names that are listed in both tables, and there are no nulls. A left join brings in all the information for the rows from the table on the left, siblings, and any information from the table on the right, eye color, for rows with the same name as the siblings table. Therefore, we get all the information from the left siblings table, and for the names that are also listed in the right eye color table, Taylor and Alex, we also get their eye color. If a name from the siblings table is not present in the eye color table, we get a null, such as for Shannon and Tracy. Let's see what this looks like in Tableau. As you can see, a left join pulls in all the rows for the table on the left and fills in from the table on the right when it can, with a null if that name is not present in the table on the right. In a right join, it's the reverse. We have all the names from the right eye color table, and for those rows, we get the sibling information if it exists. As you can see, the output list of names varies between the left and right join because we're changing which table comes first. Shannon and Tracy do not exist in the eye color table, so they show up in the left join only. Morgan doesn't exist in the left table, so she shows up only in the right join. An outer join brings in all names listed in all tables and fills in nulls wherever there isn't information for a given column or row. That's a quick primer on join types. As a reminder, not all joins are supported by all data sources. Although unions are not technically joins, it's worth mentioning them in this video. Unions are another way of bringing together two or more tables. While joins can be thought of as horizontal, adding columns to an existing table, union can be thought of as vertical, adding rows to an existing table. Note that union can be performed on specific files brought into the data source page, or by a wildcard search through the directory. Tableau follows the behavior of union all. That is, all rows will be returned in the union even if there are duplicate values for some rows, such as here for Kai. In Tableau, new fields are generated with the table name, which indicates metadata about the union's source. Finally, it's worth noting that if the field names don't match across the union data sources, Tableau will function similarly to an outer join, appending the new rows and the new columns, with nulls as needed. If the new columns should be considered the same field, the columns can be merged in the data grid. Imagine you own two retail chains, Office City and Coffee Chain. You capture your Office City data in one system and your Coffee Chain data in another. Data blending is one way of combining data from multiple data sources into a single view. Instead of joining the data at the row level, like a cross-database join, data blending sends separate queries to the separate data sources and aggregates the results to a common level back in Tableau. Here we have two data sources in the data pane, Office City and Coffee Chain. We can easily switch between the two, and notice how the dimensions and measures change. Data blending requires at least one common field between both data sources, such as state. If the field names are different, but have common members, we can manually define the relationship. For example, we know that region from Office City and territory from Coffee Chain both contain the values Central, East, South, and West. So let's define these two fields as equivalent. We'll go to the Data menu, select Edit Relationships, We can change the primary data source to be Office City, select Custom, and add a relationship. We'll choose Region and Territory. Notice that Tableau has established a relationship between the two fields and also lists the automatic relationship, State. Alternatively, we can rename the field in one data source to match the other. Let's slowly double-click and rename Coffee Chain's territory as Region. If they have the same name, Tableau will create a relationship between both data sources automatically. Now that our common fields are defined, we're ready to start blending. First, we'll select the Office City data source. We'll drag Sales from Office City to the Columns shelf, and we'll bring State to the Rows shelf. Note that there is now a blue check mark next to Office City in the data pane. Whenever we're connected to multiple data sources in Tableau, the first data source we bring into the view becomes the primary, denoted by this blue check mark. Now let's switch to the secondary data source, and notice the orange linking icon next to State. Since we already brought State into the view, Tableau will automatically blend on it, denoted by this orange link. There is also a gray broken link next to the Region field. Because Region is a common field between both data sources, it is another potential linking field that is not being used in the current view. If we wanted to also blend on this field, clicking on the gray link activates it and creates the relationship. Let's complete our data blend by dragging Coffee Chain Sales to the Columns shelf. We now see there's an orange check mark next to the Coffee Chain data source and on the pill in the view. This indicates that it's from our secondary data source. How is this view actually built? Tableau is querying for sum of sales by state to each data source, then displaying these values together in the view. We see sales information for every state from Office City because Tableau returns information for all field members, states, in the primary data source, regardless of whether or not there is data from the secondary data source. It's important to note that primary and secondary sources are determined on a worksheet-by-worksheet basis and are not maintained globally throughout the workbook. When we're on a new sheet, the data sources within the data pane do not have orange and blue check marks to indicate them as primary or secondary. The relationships we established in the previous worksheet are not carried over. What happens when we swap our data sources and use Coffee Chain as the primary source and Office City as the secondary? We'll drag Coffee Chain Sales into the view, and then we'll bring out State. Now there are only about half the states in the view compared to our previous example. This is because Coffee Chain has fewer states in its dataset than Office City. Tableau is displaying all of the states in Coffee Chain, and then it will pull in only the relevant information from Office City. This means that any state in Office City that is not in Coffee Chain will not be displayed in the view. Performing calculations across two different data sources can be slightly different from creating an ordinary calculated field. Our current view shows state-by-state comparisons of sales data from Office City and Coffee Chain. What if we want to view our combined sales for each state? In order to combine our sales from both data sources, we need to create a calculation. Verify that the Office City data source is selected, then right-click in the data pane and select Create Calculated Field. Note this indicator telling us which data source we're creating the calculation on. We'll drag in the Office City sales, type a plus, and next we'll switch to the Coffee Chain data source and drag in Coffee Chain sales. Notice that the Coffee Chain sales look different from the Office City sales in the formula. First, the Coffee Chain sales also contains the name of the data source. This format is designed to help us distinguish between different data sources in a calculation, so we always know where a field is coming from. Second, the coffee chain sales is automatically wrapped in a sum function. Data from a secondary source must always be aggregated, and sum is simply the default aggregation. As we can see, we have an error in the calculation because we cannot mix aggregate and non-aggregate arguments. To resolve this, let's wrap our sales from Office City in a sum function as well. Our calculation is valid, so we'll rename this Combined Sales and click OK. We don't see our calculation in the data pane. This is because we're on a different data source than the one the calculation was created on. If we switch to Office City, now we see that calculated field. We're ready to test our calculation. Drag the Combined Sales field onto columns. Notice that the combined sales data is not displayed for states where coffee chain sales are null. A null from coffee chain plus a real value from Office City will always result in a null, so Tableau is computing this correctly. However, we know that our nulls from coffee chain are actually zeros, so we can adjust our calculation to account for this. Right-click on Combined Sales in the data pane and select Edit. We'll wrap the coffee chain sum of sales in a ZN function. This stands for zero null and tells Tableau to treat the nulls as zeros. Now our combined sales column accurately displays the combined sales information for Office City and coffee chain. Another common scenario when data blending is dealing with asterisks. When data blending, adding another dimension to the view sometimes results in an asterisk instead of an expected value. Why does this happen? In our current view, we're using Office City as our primary data source, so it's colored blue, and we're blending on state. Area code is only present in the secondary data source. Because there's more than one area code for most states in the data, Tableau produces an asterisk to indicate the multiple values. New Hampshire and New Mexico show values because there's only one area code in each of these states. How can we address the issue of asterisks when data blending? Try swapping the primary and secondary sources in the view. We're now using coffee chain as our primary data source, and it's blue. Verify that the coffee chain data source is selected, and now we'll bring area code out into the view. This is the expected behavior for area code, as we now have an area code listed per state. However, Office City does not have an area code field, so sales is aggregated to the level of the blend, state, and that value is repeated per area code. As an alternative solution, consider if a cross-database join is better suited to your analysis. PDFs can contain valuable data for analysis in Tableau. The PDF connector in Tableau is designed to help pull out data in tables. Because PDFs lack metadata about the data, there may be some post-connection work to be done by you before analysis. Tableau can read cross-tab data tables from PDFs that ideally look something like this, with columns and rows and a single line of data for each row. Here, the stock data starts on page 2. Let's connect with Tableau. When we select the PDF file from the connection pane, a page picker appears. We can scan the whole document, a specific page, or a range of pages. We'll look at 2 through 8. And we'll bring the first page to the canvas. One of the lines from the PDF table header is confusing Tableau. But if we turn on the data interpreter, we get our headers as expected. Each page came in as a separate table, but since they're structured in the same way with the same column headings, it's easy to bring them back together with a union. With the first table already on the canvas, we'll drag out any other desired pages tables to the union drop area underneath the first. We get a new column for table name, and if we scroll down, we can see that the union data from page 3 is aligning perfectly with page 2. This PDF was structured really nicely for import, but not all PDFs will be. As a general rule, Tableau will connect best to PDFs with a tabular structure like this, with a single row of data per line, no hierarchies or nested headers, and no subtables. But PDFs don't have to be perfect to work. We'll connect to another file, one that's not as easy as the first. The table we want is here on page 14. As a note, Tableau looks at absolute page numbers, which may or may not correspond to the pagination in the document. We'll add another data source, and we'll choose page 14. The Rescan PDF option under the Data Connection dropdown lets us re-pick which pages to look at. There was only one table on that page, but there are 3 options here to the left. Tableau detected 3 possible ways to pull in that table. If we bring out each one at a time, we can see what they contain. As a note, when unioning tables across pages like we did before, if there are multiple versions from each page, be sure to union the correct table version, not multiple versions of the same page. We'll bring out Table 1 and use the data interpreter. It looks like Table 1 has all of our information, but for some reason, 1995 through 1997 is being read as a single column. If we wanted to use this version of the data, we could clean this up by doing a custom split and splitting all columns on spaces, and then rename the split fields to the appropriate years. But let's see what tables 2 and 3 give us. Table 2 looks like the bottom of the original table. And Table 3 looks like the top. I like the column delineation better with tables 2 and 3, so let's work with those. First, we'll union them, dragging Table 2 out to under Table 3. There's a mismatch between inflows and column F1. If we select both of them and choose Merge Mismatched Fields, we now have the column as we expected. Let's rename this Water Sources. There are several rows of nulls, either because of a subheader, like Change in Storage, was read as a data row, or because a single row, like Abstraction for Hydroelectricity, was read as 2 different rows. To get rid of these nulls, we'll add a data source filter up in the right corner. Click Add, and we'll add a filter. We could choose any of these columns that have nulls. I'll use F10 and click OK. Next, select Null, and then Exclude. Then click OK, and OK again. Now those rows are gone, and we're left with just our data. But I'll undo that, because we also see that there are several types of water sources that are actually totals. We want to filter those out and the nulls all at once. We'll go to Filter and Add, and we'll select Water Sources. We'll check anything that's a header or a total from the original PDF or that corresponds to a null row for the values. Hydroelectricity appears twice, once with data and once with nulls, so I'll leave it for now so as not to remove data. Then we'll click Exclude and OK. Now we have the rows with data and 1 row of nulls for hydroelectric, but we can clean that up in a moment. We don't have headers except for this first column, but we can cross-reference the values with the original PDF and see what should be what. The columns should just be the years 1995 to 2010. I'll speed this up. We can now pivot our data so we have a column for year and a column for million cubic meters. We'll hide the table name column and change the data type for year to be a date. We'll change the data type for million cubic meters to whole numbers. And now that this is in the final column format, we can filter any nulls from this column here. We'll go to Edit Filters, Add, select million cubic meters, and exclude nulls. There are still some issues with the water source names themselves. We'll bring up the menu for this field and click Aliases. Here, we can re-alias members of a given field. We'll double-click the alias and type what it should be. Finally, I remembered that there was some structure to the original PDF table. There were categories of water sources. We can build this structure in the data pane, so let's click to Sheet 1. First off, million cubic meters is actually a measure, so we'll drag it down here. We can then recreate our groups. We'll bring water sources to rows, and we'll make the first group. Control-click on the members that should be part of the same group. We'll use the paperclip icon in the tooltip to do the grouping. Repeat, and group again. Let's right-click on this new field in the data pane and edit the group. First, we'll click Precipitation and group that, even though it's by itself, to make it its own group. And now we can rename them. And we'll name this overall grouped field Categories. If we drag the original water sources on top of this category field, we can create a hierarchy, enabling drill down in the view. The precise steps to clean up a given PDF post-connection can vary, but hopefully this video shows you some tools you can use to clean up the data so it's ready for analysis. As a reminder, Tableau will have trouble with PDFs containing subtables, hierarchies and headers, multiple rows of content that should be interpreted as a single row of data, and finally, note that colors and shading can change how data is interpreted because of how PDFs must be parsed into cells and tables of data. Tableau has optimized native data connections to both relational databases and multidimensional data sources. This video covers some of the functional differences when working with these OLAP or cube data sources. Cube data sources, such as Microsoft Analysis Services and Oracle Essbase, process and transform data from a relational database into pre-aggregated results with defined hierarchical structures. The predefined nature of a cube data source does affect some functionality in Tableau. If possible, we suggest connecting directly to the underlying relational database. When using a cube, we cannot take an extract. There is no equivalent of the other databases option for unsupported cube data sources. And at this time, Macs do not support connecting to cubes, so everything in this video is applicable only to Tableau Desktop and Windows. The workbooks using cube data can be published and will function in the browser and on mobile devices. Cube data sources allow for the definition of a KPI as a data type. Tableau does not recognize these KPI data types, but we can recreate them in Tableau just as we would when using a relational data source. When using a relational data source, there is a paperclip icon in the tooltip to group fields. This option is not available when working with cube data sources. Grouping can be done with a calculated member written in the MDX language, which is covered in the Analysis with Cubes in MDX video. To connect to a cube data source, select the server from the list of options, or connect to a local cube file. For this video, we'll be using a local cube file. In the Connect pane, choose Other Files. Navigate to the cube on your machine and open it. For Step 1, Local Cube File should be selected. Step 2 can be left as is. Under Step 3, click Connect. If you get an error, verify that you have installed the driver available under this video. For Step 4, and 5, select Supercube, and we'll tidy up the name. We're brought directly to Sheet 1, but let's click back onto the Data Source tab. At the bottom, we see the metadata view with field names, with the ability to rename fields and change data types. Unlike relational databases, we do not have the ability to preview the data. Let's go back to Sheet 1. Note that this cube is a different version of Superstore than the other videos are using. Tableau displays the dimensions and measures exactly as they are defined in the cube. We'll drag sales to the rows shelf. Tableau creates a bar chart automatically just like normal, but you'll notice that the sales field does not have an aggregation like sum or average. The aggregation is part of the cube definition and cannot be switched within Tableau. Data structure and aggregation changes will require working with the cube's architect. When we right-click on the sales pill, there's no aggregation menu option. However, quick table calculations are still available. In the Dimensions pane, you'll notice that hierarchies, including time fields, are also predefined in the cube and cannot be changed here. We'll expand Customer Geography and bring Region to columns. Let's right-click to show the filter. Cube hierarchies have a different type of filter than those in relational databases. They show all the levels of the hierarchy and allow for ragged selections, where totals from different hierarchy levels are visible side by side. Tableau shows all the levels expanded by default, but if we double-click on a hierarchy level, we can collapse it down. Let's create a new sheet and double-click Sales again. This time, we'll bring Order Dates, Calendar Date to columns. And we'll drill down to quarters. This looks similar to discrete time from a relational data source, but it does not work identically. If we drag off year, notice that the quarters did not collapse down to only Q1 through Q4. The hierarchy levels are maintained. If we right-click and show filter, we see the same hierarchical filters we saw with region, and we have limited options to change the layout. What if we want a continuous time filter? If we look at the order date dimensions, there are non-hierarchical date fields with a different icon from the calendar date hierarchy. Let's click on the icon in front of Tableau Date. We see that it's string by default, but there is an option for date. The icon changes to a calendar, and if we bring this field to columns and remove quarter name, we see that it's a continuous field. However, we should only use continuous dates for filters and not as dimensions in the view. When using cubes, continuous date is always at the lowest level of detail, and Tableau cannot roll it up to a yearly or monthly continuous view. So let's undo this, and we'll just use the Tableau date as a filter. Note that we now have the continuous date slider available in the view, and we have all the regular options for interactive filters for dates. If we want other filters to look more like those that Tableau creates in a relational data source, we can use sets. Expand the product group hierarchy and right-click on product category. We'll choose Create Set. Let's name this category Filter. We'll select Furniture, Office Supplies, and Technology. This shows up as a set at the bottom. Let's bring sales into the view, and then if we right-click on the set and select Show Filter, this interactive filter functions similarly and has all the display options of a regular interactive filter in a relational data source.